My name is Edgar Hertwig. I'm a professor of industrial ecology here at the school. It's a real pleasure today to introduce today's speaker, Professor Shelie Miller. She is spending time in Washington right now as a fellow at USAID, but her home institution is the University of Michigan, where she works at the school that's quite similar to our school, the School of Natural Resources and the Environment. And she is an industrial ecologist at heart. She does a lot of things that we recognize very well. I'm glad to see some of the students from our course here. I think you will recognize a lot of elements of what you learn in the class in the talk by Shelie. And the topic of the talk is how to do a sustainability assessment for future technologies. So please, Shelie.
So thanks so much. It's a really great pleasure to be here, and I feel like you guys are my people. So talking to interdisciplinary environmental crowds, it always feels good to talk to people who aren't necessarily rooted in a particular discipline, but have really big, broad questions about the entire world. Just to make sure, can everybody hear me in the back? Pretty good? Okay, excellent. So what I'm going to talk about today is thinking about sustainability assessments of things that don't exist yet. So it means that I'm going to be wrong, because I can't predict the future any better than anybody else. But hopefully I can convince you that even though we don't have data and we don't actually know what's going to happen in the future, it's still important to actually be able to do. And so I am an industrial ecologist by training. I have a lot of methods that are informed by life cycle assessment. I'm not sure what I can say today could actually be classified as a life cycle assessment, but I do pull a lot from life cycle methods. So what we're really talking about is trying to understand how to deal with future technologies in this idea that trying to mitigate problems before they actually occur. So rather than going down a pathway and say, oh, wait, no, we should have designed that differently, how do we actually be really proactive and thoughtful and strategic about new technologies that are happening? But before we go and talk about the future, I'd like to talk a little bit about the past. So think about it. It's 1908, right? Model T is just rolling off the assembly line in sort of massive new innovation and creativity as far as being able to mass produce a consumer good. And we're just at the start, we're just at the cusp of personalized, affordable transportation. So, 1908, you have perfect hindsight right now. How do you redesign the system differently? Knowing everything that we know about the automobile, knowing about the incredible amounts of economic activity it has brought about, personal freedom it's brought about, just general overall being able to access and transport ourselves, and all of the great things it's brought about, but then also all of the consequences as well, as far as fossil fuel use, climate change, as far as smog formation in cities, asthma, congestion, right, and loss of work time and loss of productive hours, overall changing of urban design, its influence in creating sedentary lifestyles, not sedimentary, but sedentary lifestyles. So think of all of those things, perfect hindsight. What do you do differently? What are specific design changes you make to the technology just as it's starting to roll off the assembly line? What are policy changes that you might make as far as positions, as far as energy resources, efficiencies in cars, even design of cities and urban environments? What would be your top thing that you would change in 1908 that you wish you could go back in time and do now? I'm not sure, right? And there's lots of different approaches to that. There's lots of different strategies to that. And so I think it's safe to say that there's not going to be anything we could do that is going to completely alleviate all of the negative consequences. But there are some things that we could have done if we had perfect foresight. And even if we didn't have perfect foresight, but really thinking strategically through on how we could have done things differently. And so we have a number of 1908 moments right now as we're standing here. And so the things I'm interested in are not just emerging technologies, but transformative technologies. So those little computers that are in our pockets all the time, that are changing the way we interact and consume and behave, what is that going to do for us 50 years in the future? Or things like 3D printing and distributed manufacturing, or automated transportation, right? Automated mobility. So we're going to talk a little bit about those things and how I see them. Hopefully, we get a sense already of why we care about emerging technologies. But for anybody who's ever had a design class, you may have seen this before, but I think it's a really good thing to keep in mind. If we look at how a design stage of a technology, a process, a product goes, and we talk about the stage of the design process and the information we have about the system. Really early on, we have very little information about the system. We don't really know exactly what form it's going to take. We don't have the inventory data to have a really true life cycle assessment. And as it goes on, we get more data. Conversely, though, our ability to change the system is pretty much entirely in inverse. When we're just having an idea, when we're just in the prototyping stage, we can change any number of things about what's happening. But once it's actually gotten through to the actual production and implementation side, it's much harder to make major transformative change. You can make marginal changes, but only, fairly small ones in the overall process. And that's why it's so important to think really early on in a design process about, okay, this is a really exciting idea, but what are some of the unintended consequences that this road is going to lead us down? So and again, we're dealing with modern technology, modern design, but things as simple as cars, which we've lived with for the past century, are not really available in much of the world today. I'll talk a little bit later about a case of refrigeration, something that we take for granted, but what happens as far as how refrigeration can absolutely transform the global food system, right? When we talk about in changing overall wealth of the world and changing consumption patterns, some of them are going to be new technologies, but some of them are going to be old technologies that are being deployed in new contexts, that we have exactly the opportunity that we had in 1908, just with all of the hindsight of what's happened in the developed world, but for the developing world. So, as Edgar mentioned, I'm really excited that this year I'm taking my sabbatical and working at USAID through what's called the Jefferson Science Fellows Program. The idea behind it is to try to integrate science into policy. I'm not sure that any of us will be particularly effective in that, but if nothing else, it gives us some context of how the government understands science and how it uses science to make a decision. And so I'm actually at USAID, whose mission is really poverty alleviation throughout the world. And the team that I'm in is actually innovation adoption. So how can we get mass scale adoption of new technologies for poverty alleviation in the developing world? I'm only 2 months in, but I know I'll be talking through a number of you throughout the day, so I'm happy to talk about that role as far as negotiating between science and policy and really thinking through, all right, how do we do this when we're talking about the developed world context? But then also there's lots of ethical ramifications and other things to think about when we're talking about the developing world. So I'm happy to talk about that as well. So as far as my overall research questions and what I'm specifically looking at in my research and through my research group, is trying to understand how different adoption patterns are going to lead to different environmental outcomes. And one of the things I hope to convince you of, if you're not already convinced, is that a technology does not have an inherent environmental profile. we tend to kind of think, okay, this technology is bad and this technology is good. And that's not actually necessarily the case. It often comes down to how we interact with a technology, right? And what our adoption and behavior patterns are surrounding that technology that leads to its overall environmental outcome. So I'll show you a couple of examples of how different adoption patterns, or something as simple as price, can actually change the environmental impact of a product or service. And then, of course, the idea is how could we redesign the system to mitigate some of the environmental problems. Before I move on, does anyone have questions? Everybody's on the same page as me where we're going with this. Okay. And just so you know, I'll give you two case studies, one that's fairly mature, talking about bioenergy and biofuels, and then one that we're working on right now, again, that's refrigeration in developing countries. Okay, so my colleague Greg Shelie and I, we were talking about this idea of emerging technologies, and specifically the idea of transformative technologies. There's lots of new technologies that we would consider emerging and new. Not all emerging technologies are going to be transformative, but the ones that I find particularly fascinating are the ones that are going to overall change what we are as a society in 30, 50 years, similar to the personal automobile. Okay, so what we said is when you bring a transformative technology and put it into the existing system, there's going to be multiple ways that you have to analyze the sustainability of this product. And again, this goes with the idea of life cycle analysis methods. I know many of you have been taking industrial ecology, thinking through LCA. This is not necessarily a consequential approach or an attributional approach. These are overall factors that we can start thinking about how a transformative technology is going to change a society, and then what are the types of things that we have to keep in mind. So there's going to be what we've called intrinsic factors. These are things that are about the technology development itself. This is the choice between using peanut oil-derived biofuels in the Model T Ford versus gasoline, right? So these are technological choices that we make about the system itself. There's also what we consider indirect factors, and this happens at the interface between the technology and the existing system. So it has to do with, all right, well, something was there before this technology existed. Is it displacing something? Right, so if we have our smartphone, what is it actually displacing, right? Do we actually still have cameras anymore? It's probably displaced many of the digital cameras that we used to have because everybody uses their smartphone instead of their cameras, right? And so there are things that it's going to take off the market, but then there's also going to be things that it adds to the market. It's things that it coexists with. So understanding overall what else is changing in the overall landscape of society. There are things like rebound effects. So thinking about the economic space and how that can change. And the big one is really behavior change here. So how do people actually change as a society, right? Do they change where they live? Do they change how they interact? Do they change how they consume? Or does it enable different patterns of behavior? That's really difficult to get at. I'm an engineer. I'd prefer not to have to deal with people. But as it turns out, behavior is a really important element to think about when we're assessing technology and environmental impacts. And so we also have things that are external factors to the system. So these are things that are not technology specific. They don't occur because the technology happens, but they're happening because the future is evolving and society is co-evolving anyway. So it could be that the electricity grid is changing. It could be that the population is growing and that the growing population is becoming wealthier, right? And so there's exogenous effects that are happening on the system. So there's all sorts of things that are going on. And so it would be incredibly difficult for any single researcher to deal with all of this. And I don't think we should, and I don't think we can. And so, hey, we're in an interdisciplinary school, right? And so this is actually an incredible call to arms of saying, if we're going to look at future technologies, we need economists and behaviorists and ecologists and economists and engineers and urban designers and the whole realm and suite of people to be working on trying to understand the impact of future technologies. Because a good study on the efficiency and functionality change of how technically vehicle miles traveled will change if we put in autonomous vehicles is going to be an incredibly difficult study. And that's just one piece of autonomous vehicles, right? Similarly, looking at rebound effects, an entire big economic study that's necessary. Similarly, technology displacement. And so what we need when we're thinking about these big transformative technologies is an integrated interdisciplinary approach. Okay, so my general approach for our research group is to figure out some sort of adoption model. How are people going to use a new technology or process? And put on top of this some environmental information, usually derived from the LCA literature. And then try to figure out two things. One is the traditional method of a per functional unit approach. But when we're actually talking about new technologies, we also care about change in the aggregate, right? So something might be better on a per functional unit, but overall lead to increased greenhouse gas emissions, right? And so you could see that just as far as volume of product that's being sold, right? So trying to understand not just on a per product sense, is this better, but overall, are we better or worse as a society if this new product comes to being? Okay, my approach is to identify plausible scenarios that could occur. We know we can't predict the future, right? But what we can say is there are various paths to take with this new technology. You could end up here in pathway A. You could end up over here in pathway Z. We know that A is preferable to Z. Let's try to take the steps where we're going to get closer to A than we are to Z. And so try to identify critical steps along the way where we know, hey, if we adopt this way, it's going to lead to negative impacts. If we go this way, they might be more beneficial. Okay, luckily, we have some good research on our side as far as how people adopt technology and innovations. And it's fairly well developed as far as what people do and behave, and it always pretty consistently follows what we call a diffusion of innovation curve. And you see it's considered an S-shaped adopter curve where you have, at the very early stages, early adopters who are driven by information, and they have very specific characteristics as far as innovating in technology. If they like the technology, they may influence their sphere of folks, and the technology will take off until eventually even the laggards may take up that technology. And this is true of pretty much any new thing that happens. It's true of goods and products, but it's also true of software or other innovations that happen on the products. It's also true for things like communication and memes, right? Where you start out really slow penetration, someone invents it, and then it explodes, and then 2 days later you never hear from it again. But it follows that exact same pattern, regardless of what it is. The time scales may vary, the overall market penetration may vary, but it still has predictable points along it that we can use to help understand diffusion of new technologies. So we rely heavily on this type of literature. There are certain people and categories that fall within different adoption spaces, so we can get a good sense of new technology. Okay, so this has all been fairly theoretical. I want to ground it in a more concrete example, which is looking at switchgrass as a potential biofuel as a substitute for gasoline. So this is a topic that I've worked on quite a bit. The US has committed to 36 billion gallons of renewable transportation fuel by 2022. We are not going to get there. One of the reasons is because oil prices are very low. But one of the things we wanted to say is, well, it's great to come out and have this policy, but what are people actually going to do as far as making biofuels? It's not like the government can come down to farmers and say, you will grow a new biofuel crop, right? There's incentives that you can do, but how do you actually think about who's actually going to take those incentives? And if you're talking about a specific new crop, such as switchgrass, which is incredibly productive, but no one grows it yet, how do you actually think about adoption of a new crop? And then even more, how do you think about how adoption of that new crop in different contexts might change the environmental impact? And so, as it turns out, there's going to be a very different impact if you take active cropland and convert it to switchgrass, which is a perennial. It is low input. As far as nitrogen requirements, it's low pesticide, and it's fairly low in harvest energy. It's going to be very different if you take it out of cropland than if you dig up things that have been in prairie land for the last 20 years and put that into productive agriculture. And so one of the things we wanted to explore is how the price of switchgrass, the offering price of switchgrass, how that was going to change the environmental impact of the biofuel made by switchgrass. So I will say that again, that the price of the good is going to determine its environmental impact, right? Which is, again, not necessarily the most intuitive thing ever, because you think, well, biofuel, switchgrass, it's either good or bad. Is it better or worse than gasoline? That's what people ask me all the time, and I say, well, what price is it at, right? Because as it turns out, as I'll show you, the price changes the environmental impact of switchgrass, and here's why. So we did some agricultural modeling, and the top one shows cotton, actively managed high-intensity cotton farming to a perennial grass, right? And so we start out, and red is system carbon, higher is better, and so we plant in year 0. Once we plant switchgrass from a cotton field, it does nothing except suck up carbon into the soil, and things are good. Again, we're just looking at what's happening on the land. The overall LCA is much bigger. If you look at water quality effects from planting switchgrass on cotton, you have lower is better, lower nitrogen emissions, and you have overall positive effects when you plant switchgrass on cotton fields. Okay. But let's take things that have been in conservation reserve program land. So this is, we're paying farmers to actively not grow their land. There's been carbon sequestration in these lands over time. But now they're saying, hey, it actually makes more economic sense for me to grow switchgrass in here than to take the conservation reserve program payment. And so what we see there, again, red is carbon, higher is better. You end up seeing what we call a carbon debt when you till up the soil. Soil carbon oxidizes. Carbon dioxide goes into the atmosphere. So for the first few years, there's a net carbon emission from the soil. But then if the switchgrass stand is there for long enough, it builds up over time. And so you have somewhat positive carbon effects, but not nearly as good as the cotton case. Water quality, it's about the same, where again you have, when you disrupt the soil, you have a big nitrate plume, but then it recovers fairly well. And so you have these two cases. One, if you take active land, overall, again, just looking at the system of the land itself, not the overall environmental impacts or any indirect land use change, you have general positive effects and marginal positive effects for marginal land. And so here's what we see for overall. You see the cotton is overall much better for carbon sequestration from direct land use change, whereas uncultivated grasses are pretty much almost negligible. Same thing for nitrate reductions. Okay, so two different land uses. One is more preferable than the other from an environmental impact stage, again, just looking at direct land use. But then the question is, who's actually going to plant this stuff, right? And so as it turns out, that planting decisions are going to be highly dependent on what a farmer can get for their current land use decisions versus what they can get for switchgrass. And so we ran this model to show all of the various break-even points between what they're currently doing with land use and what they're doing, when they might consider planting switchgrass instead. So green is cropland. It consists of the same profiles as cotton and those types of things. You can see that farmers aren't even really going to consider planting switchgrass until it's at least $40 to $50 a ton, right? But more marginal lands and things like pasture lands are going to start breaking even a bit earlier than that, right? And so if you're giving an offering price of $10 or $15 or $20 of switchgrass, well, the environmental impact of switchgrass doesn't really count because no one's going to grow it anyway, right? And if you're giving an offering price of, 110 when we're all at saturation, well, then the switchgrass is going to be pretty static as far as its environmental impact because everybody who would be growing it would be growing it. But then there's this fairly large transition zone of price, and they, right now, just so you know, switchgrass would be between $50 and $55 per ton. And so you're talking about the zone where you're seeing massive amounts of potential change of one land use over the other on these distribution curves, where all of a sudden these fairly small changes in price are going to lead to changes in environmental outcomes, right? And so this is what we see. And again, fairly limited study just looking at soil carbon here. I also have it for water quality. But you can see that as switchgrass price changes, so does the environmental impact by about a factor of 6, right? And so you can see that at high prices, you're going to have a change in emissions by about 87% from the baseline. So actually, when you take it out to ethanol, so per BTU of ethanol, high switchgrass prices are actually going to influence the LCA quite a bit. Low switchgrass prices basically don't change the LCA of switchgrass at all, right? And so this is a very concrete example about how economics are going to drive behavior change, how that behavior change is going to change the environmental impact of a product, right? And so what I want to point out from this particular case study is, and I feel like this is an actually really important point, is this isn't an uncertainty effect. In LCA, we often say, oh yeah, well, there's a lot of uncertainty in LCA, and there certainly is. But the correlation between price and carbon sequestration in soils is not an uncertainty effect. It's an actual causality, right? Now, there's certainly uncertainty in the data, right? But there actually is an influence of price on actually changing the environmental impact of something. And so what we see here is increased price leads to improved environmental impact, again, on this fairly small scale. But you can have all sorts of complicated patterns, right? So you could have increased price leading to decreased impact. You can have the aggregate impact as far as the overall watershed changing in a different way than carbon, right? Or you could have the aggregate impact as a different influence than a per functional unit impact, right? So you could improve the functional unit on a per gallon of ethanol, but still increase overall nitrate to a watershed, for example, right? So all of these sorts of adoption patterns are really important to sort of start thinking about as we're talking about overall transformative change. Okay, so that's my first case study. The next one is a bit more theoretical, but hopefully gives you a sense of the different types of adoption and behavior changes that might be really important to think about talking about future of the world. Okay, so that's refrigeration. When we think about really exciting new cool technologies, refrigeration is perhaps not the first one to come to mind, but I am psyched about refrigeration. Like, I don't know, so this is emerging issues associated with the introduction of the cold chain. I tell people I'm working on the cold chain and everybody goes, what's that? And I go, the cold chain is awesome, because the cold chain is what brings us everything we have as far as lunch today, right? So the cold chain is access to temperature-controlled environments throughout the entire food system. This is huge. when we start thinking about how we as an industrialized nation get our food to us, we would not be able to have the system we have without the cold chain, right? And so it changes geographically where our food is grown. It changes the level of industrialization that's possible. It changes the types of food we have access to at various parts and seasons of the year. It changes lots of things, right? And so I know that there's lots of people probably that are interested in the food system. And so this is one element of the food system that our research group is really starting to tackle because we think it has tremendous potential impact on overall global energy use in the next 30 years, is development of the overall global cold chain. Okay, so just as, much of the world is still in wet markets or smallholder farming, right, where you're either growing your own food or you're living in an urban area, usually with fairly low animal protein access, right? And what you do have is usually slaughtered on site or very nearby, right? And so moving toward, all right, grocery retail and all of the various things that that entails. So I'll talk you through that a little bit here. Just to give you a scale of refrigeration, in case you don't think refrigeration is a big deal. Currently, with our current food system, refrigeration is about 1% of GHG emissions worldwide. That's just due to energy from refrigeration and refrigeration leakage, so refrigerant leaks. Assets are valued at $167 billion, and there's about 7% growth per year in this topic, right? So this includes everything from being able to import produce from one continent to another, and refrigerated ports and warehouses and distribution systems throughout the way, freezing on point of contact, right, at a farm or refrigerating there, and then transporting it throughout the supply chain. Now, the stated purpose of refrigeration, or what we like to think of as the purpose, is it should reduce food spoilage, right? So you refrigerate, you refrigerate a piece of meat or a carton of milk, right? And it should last a whole lot longer in a refrigerated environment than in a non-refrigerated environment. Makes sense. And the interesting part of that is, when we look at food waste in the developed world that has a cold chain versus the developing world that does not have a cold chain, the waste rate of food is about the same. But we have refrigeration. And so our food waste rate, that is really difficult to say, your rate of food waste should be much lower when you have refrigeration, but it's not. And as it turns out, given the amount of food we consume in the US, food spoilage is attributed by about 2% of our GHG emissions, right? So you're talking on, at least even just climate change basis, a major impact here as far as refrigeration. So why? Why are our rates so different? It goes to that pesky behavior thing again, right? So when you look at the developed world versus the developing world, the parts of the supply chain where food waste happens are very different. So in the developing world, it happens pre-market, right? It's not being able to efficiently collect from farms and get it into the cities, and it spoils before you actually get your customer. There's very little waste in the system, relatively speaking, in the developing world, and it all rots in our refrigerators, right? Or we overconsume food, and our portion sizes are much larger. Part of that is part is enabled by refrigeration, but overall, our food waste happens in a much different context, and it's usually by choice, not by a problem with logistics, which is what's happening in the developed world. Okay, so we're interested in studying this. And so taking it through our overall lens of thinking through intrinsic factors, indirect factors, and external factors that we want to study and partner with others to study, because we don't always have the capacity within our research group, here are some of the things that we want to look at as far as the cold chain. We want to look at, okay, we put in refrigerated warehouses throughout China and in the ports, and we put in now grocery stores and all of that, what is the coolant leakage going to be? What are the new types of refrigerators that are going to go online? So most of the refrigerators in the current cold chain could be vastly improved, and we expect the new refrigeration systems to be logistically more favorable in developed world contexts. We also do expect increased shelf life of food, which would change some of the logistics and food waste early in the supply chain, right? But then there's this issue of transportation distances, and it goes to the idea of now industrialized food systems are possible, right? So when you talk about milk production in the United States, you know, there's California and Florida and Wisconsin and a few sort of concentrated places where there's milk production, and that's enabled by the fact that you can transport milk anywhere you want in the United States, right? And so you have much larger transportation systems because we're able to refrigerate the entire way through. And so you don't necessarily have localized dairies. And so there's lots of things embedded in transportation systems. We know the distances increase, but also there's supply chain overall logistics that are going to change. We also have a number of indirect factors. So I will admit that this research happened, the idea for this research happened. I was listening to NPR, and they were talking about how there was a Chinese company that was starting to freeze their dumplings, and wasn't that cool? And I thought, oh, well, that changes things. Because this company was famous in China. They were basically a storefront company, and they were just, you know, basically selling what they could to their storefront. But now they developed a manufacturing facility that were freezing it for household consumption, where people had personalized refrigerators and could buy a frozen product that, by the way, has more embedded energy to it, put it in their freezers, and then eat it at a later date, right? Potentially getting freezer burn, potentially not ever getting to the consumer. So a cold chain will actually increase your frozen foods, your convenient foods, also your access to dairy and meat, because again, transportation distances are enabled to be greater. Now, you're going to say, yes, but some of that's wealth effects. Absolutely, some of that is wealth effects, right? And that will be an external factor that we have to deal with. But it's a wealth effect that would not be possible if it was not enabled by the cold chain, right? So we have that. We also have changes to purchasing and consumption. If you bring in modernized grocery stores to areas that do not currently have modernized grocery stores, what does that do as far as the influence of how we behave as a society and how we change our relationship to food? Overall, in the developed world, particularly in the US, we have overconsumption behaviors. We do one big grocery shopping trip at the beginning of the week. Everything looks good. We buy more food than we could possibly consume, and then we end up throwing it out by the end of the week. Again, some of that is wealth effects, but some of that is because we can actually hold it in our household for a week instead of just buying for that day, right? We also have changes to infrastructure, all of the grocery cases, all of the refrigerators, all of that. And then external factors, things like wealth, things like overall demand. That's a huge change to the system. That is a transformative aspect of the food chain, right? And it's just refrigeration, just simple refrigeration, right? We know how to do that. We've known how to do that for, you know, at least a century. But now when we're talking about putting it in developing countries, how do we want to change this, right? What are the types of things? Some of the things we'll be able to actually put incentives or barriers to help change things. Some of them are just going to be things that happen anyway because people behave in certain ways. But are there certain ways or certain things we could incentivize or disincentivize that would lead to better environmental outcomes than if things just happened across their course of things? Here's just a quick slide of a comparative analysis to see where things are coming from, put together by my current PhD student, Brent Hurd. This is the blue is associated with a decrease. The red is associated with an increase. This is just a comparative analysis between North America and Sub-Saharan Africa. So systems that we feel are fairly well characterized by fully integrated cold chain and non-integrated cold chain. And where actually the major changes are coming from. Again, this doesn't have to do with causalities here. It just has to do with overall where we see things. So what you see is if Sub-Saharan Africa, the change between the two, the developed world, North America, and the size of the square, sorry, represents the overall size of change, that you have small, generally positive changes in embodied energy, right? So we're more efficient, we waste less early on in the supply chain. The spoilage rates are much better in the developed economy. So overall, you get positive influences or reduced negative impacts overall due to food actually spoilage. But the demand shifts tend to be the ones that are really responsible for major differences. So, and this is something that we kind of already know, that shifts toward meat and dairy are going to be large drivers in an overall embodied GHG emissions of the food system. And so changing from a primarily vegetarian diet to one that is very meat and dairy intensive is going to have massive changes in embodied energy. Okay, so I'll take you really quickly through how we're going to do this and what we're thinking of, and then I'll open it up for questions. So when we talk about food production and the energy-water nexus, one of the things you look at when you talk about causalities is everything's a positive causal linkage, right? In order to make energy, you need water. In order to make water, you need energy. In order to have food production, you need both. So if you increase the scale of food production, you're also increasing water and energy, and then they have their own reinforcing loop there. If you add refrigeration into the system, there's actually a balancing loop put in place. So refrigeration actually requires more energy, but should, at least in and of itself, reduce food waste, which should cause a negative pressure on the food production system and cause overall decreases in energy and water. So one of the things we're really interested in is which one of these forces actually wins out, right? Are we going to see positive or negative effects of global energy? And then even expanding it further, it's taking that pesky consumer into account, where when you increase refrigeration, you increase consumption, which increases refrigeration, and increased consumption leads to increased food waste. And so how do all of these factors play out? What are the major forces in looking at these and trying to be able to get some sort of causality of how these various factors come into play? So that's my food chain, cold chain topic that we're just really starting to delve into now. So Dr. Cito asked me to hopefully cover these questions throughout my talk. Hopefully I have gotten to them, but if I have not, certainly we should talk about them further. Hopefully we got through my research questions. Obviously, interdisciplinarity is big in this type of work, and we need an interdisciplinary approach. And we're still working on how to actually integrate this into policymaking, but hopefully I'll have better answers as far as how to do that in about a year. So with that, I will thank my research group as well as the National Science Foundation, and happy to open it up for questions. Yeah. Yeah, no, you.
Hello, my name is Oscar. I'm a third-year student. I wanted to say how exciting this talk is because just a month ago there was a talk at the business school from United Technologies that sell refrigerants, and one of the presenters wrote a book called Food Foolish, and he believes that refrigerants will decrease greenhouse gas emissions because of what you just refuted around preserving food longer. And I wanted to connect to your third point about connecting it to policy and business. And I think it's so important that this information is spread to business and they really start to think about the behavioral aspects of this. And I'm curious what other policy groups or industry groups you're interested in pursuing and teaching this research.
Sure. So one of the big partnerships that we've been working on forging is with the Global Cold Chain Alliance, Who knew such a thing existed, right? But the Global Cold Chain Alliance is about 1,500 industry partners that have some aspects of the cold chain. So they're either food retailers, they're suppliers, they're warehouse builders, they're actually refrigerant makers or refrigerant processors. And so they, I will say, have much a similar bent where any refrigeration has to be better. And so, you know, I'm carefully starting to talk to them to think about some of the broader impacts and, you know, how they can potentially be, you know, think through what they could actually do. It's difficult, though, because a lot of it is the behavior side of things. So when you're talking about the technology aspect, what could we change and control about the technology to inform behavior change? You know, we're going to need a whole lot more minds on that because we're not really sure how to do that. Because sure, we can design a more efficient refrigerator, but that doesn't necessarily get to the bigger questions. So we are in conversations. We'll see exactly where we get, though. That's a good question. Yeah. Oh, or if it's easier for you to choose, that's fine.
Hi, my name is Greg. I'm a first-year MEM, environmental management student, and I was wondering how the movement back to like sort of a locavore movement and sort of the local eating impacts the feedback loop diagram that you showed, because consumer habits can increase refrigeration, but there can also be sort of regional movements away from refrigeration with local, like hyper-local eating. And I was wondering how that affects the overall system.
And that's a great question, and we don't have the data yet, so we haven't actually fleshed it out yet. My assumption will be it will certainly help. You know, when you look at overall food miles versus, say, if you're talking about meat versus beans, you know, the transportation distance usually isn't the thing, but you know, the overall movement of local eating really being connected to food, you know, I think that is going to have a factor there. How big of the factor? I don't have a sense yet, but it's one of the things that we're definitely interested in getting data, figuring out how to get data. My sense is that it will improve. Will it overall transform? Probably not, is my guess. Back there? Sure.
I'm Dan. I'm a first-year PhD. My question has to do with your analysis of the switchgrass example, and I'm wondering how you account for farmer behavior, which is kind of notoriously unusual, and the normal innovation diffusion curves don't really account for that. And thinking about that, how does that inform what you might say to policymakers or something like that?
So I actually took all the math out of my talk before this. You're welcome. But the way we actually deal with that as far as the farmer behavior piece is we actually do an agent-based model to figure out those price-based curves. And what we do with that is there's three major sort of knobs we have on that farmer decision process of whether to grow or whether to keep what they have. And that is their overall profitability, so how different price would be. But then also their risk tolerance, which has to do with things like demographics and those types of things. That's actually fairly well studied in farmer populations. And then the third one that actually has a pretty major effect is the social network and the familiarity. And so thinking about how do you actually, it's one of those things that you don't want to be the first one to try something new. But if you already know 3 people who are doing it and they're making money and they have a market and they're happy with the product, then you're more likely to adopt yourself. And so we basically have a social contagion model that runs where it says, okay, getting those first farmers to start is going to be difficult. So maybe what you need to do is seed farmers and basically pay people to grow and talk about the product who are leaders in the community, and through extension agents and those types of things, really build up the social discussion, because it seems like once you get over the profitability hump, that next piece is knowing somebody else and having that experience curve that's going to be the thing that really makes it go. Sure, who's close? Yep, right there.
Hello. Hey, my name is DJ. I'm a research scientist here. Really enjoyed your talk. I've heard this idea of refrigerating China's food supply chain a few times, but I was curious if anybody has maybe studied the sort of the behavioral aspect, the cultural aspect of that. Because I grew up in China, and then first, like in terms of economics, it's hard for me to imagine that refrigerated food can be cheaper than locally grown fresh food. But growing up in China, I think my attitude towards this is more like, if I had to pay more for food, I'd be much willing to spend it on local fresh food. Because I feel like this is just my impression, I don't have data, but I feel like Chinese people are less forgiving about their food not being fresh. I guess we can all agree that if we go to, even here, if we go to a local, strawberry farm to pick fresh strawberries, they taste better than strawberries in a box that you can find in grocery stores. So I feel like it may not be it's probably not a logistics or a technology issue in China with this refrigeration idea. So I guess I was just curious, has anybody studied that aspect of food supply in China?
So there's starting to be studies. And so again, as you point out, there's major behavior and cultural aspects associated with our relationship to food supply. And so just bringing refrigeration in is not necessarily going to change how people consume, but it could enable different shifts. There's a couple of things. One is it's the industrialization aspect that is potentially going to drive prices down, that make things like frozen packaged convenience food cheaper, or at least competitive with local food systems. The other is, and one thing that's shown up a fair bit in the literature, is a preference toward globalized brands in the China food market. And so sort of this trust aspect, when you're starting to talk about more industrialized food, trust in sort of the multinational brands, the McDonald's of the world, what have you. And then that as far as overall shipping distances and transportation. But yeah, so there's starting to be behavioral studies and trying to understand how changes in the food system happen. Again, we're not going to necessarily try to predict exactly, but we'll try to use the information we have that say what could happen in various scenarios. What would the potential penetration of industrialized food or grocery store food end up being? But yeah, no, that's a very good point. Well taken.
David Deese, a visiting professor. Given that a lot of the early adoption and key technologies that reduces greenhouse gas emissions hasn't been in the US, but in other countries, question, how do you incorporate the radical differences that an anthropologist would give you on cultural context, and then also a political scientist would give you on governance and opposition on religious or rule reasons into the methodology? So,
again, I think that's a great point, and I think it is a cautionary tale of models gone potentially wrong, right? Of saying, all right, so we're just going to model this, and we know that it's going to happen exactly
around the world. I mean, you're in USAID, and I appreciated the graph on Africa, but how, from a methodological point of view, again, the same
the way it was in the developed world, and this is how it is. And I think that really comes to the interdisciplinary aspect of things, of saying, all right, well, we have this model, and it's a toy model, but let's actually talk to people who really understand the context of things. And what are some of the things that I, from an engineering sort of headspace, really don't understand about the cultural aspects, the regulatory aspects, the political aspects of this context that need to be incorporated here. And maybe that changes a factor a small bit. Maybe that totally changes the sign of that factor. And so, again, I don't think, it's important to think about the future, and it's important to kind of figure out, okay, what are the general trends? But to say, all right, any one model can incorporate all of these things, well, that's just foolish. But to say, all right, well, here's a beginning of a model to start a conversation, And let's start this conversation. Let's bring it to the technical people, and let's bring it to the policy people, and let's bring it to the social scientists and say, all right, well, what do we have right here and what do we have wrong here, and how would being wrong actually change the model in one way or another? But yeah, that's a great point. Yeah.
Hi, Jonathan Cruns, postdoc. So now that you have this methodology and it's been applied to a number of cases, do you have an answer to your initial question about the Model T? Is there something that you feel like you could change? Or could you walk us through kind of one way of thinking about that, knowing, you know, this perfect hindsight kind of
I was worried someone was going to ask me that question. So actually, I'm thinking about putting together a seminar next year on exactly that question and having people try things out and do analysis as far as just general order of magnitude analysis on what could have happened. My gut feeling, and I have no idea if it would be right or not, would be urban design. And
so nothing having to do with the actual
not to do with the technology itself, but urban design policies that would change the way people behave in the context of cars. That would be my immediate gut reaction. All right. I think that's everything. So thank you so much. I had